Hello everyone, my name is Liang Tong and I'm a graduate student from UF Department in Electrical and Computer Engineering. Here is a presentation of my final project for Network Science and Application extracted by Dr. Oliver Wu, and the title of my project is Unveil Your True Willingness in Social Network. Okay, here's the contents. My presentation consists of 5 parts. The first is introduction of my project, then the description of blind spots issue that is a core part of my projects. Then I will give you guys some experiment results and do some evaluation job. The fourth part of this related work. Then, of course, finally I will give conclusions and summaries of this project. Okay, first, I will introduce how a social network is built. Yeah, if from one user, it can connect with other users while searching the internet with some information. We call it keyword search. After that, they build a small social network between each other, and the user will not stop searching other user to expand his social network. Gradually, the social network scale increases with more and more users being involved. That's just like roots. The first user acts as the roots of the tree, and it will extend to other contacts and bring them into this social network. That so they kindly form social network. We call it social circle later. Okay, here comes the problem: blind spots. Numerous updates from these frequent online contacts often overwhelm people's demands. Constrained by limited spare time and energy, users in social network often feel difficult finding valuable information among vast news coming to them every day, because people have to select useful information connected with them while connecting news they don't really care. This is well understood that because everyone has someone who he is interested in, and some field attracts him, that he just needed this information that he cares about, that he will throw away this information that doesn't do anything with him. So to judge people's willingness, I introduce the concept blind spots. Let me give a definition of blind spots. The blind spots refer to on-surface willingness, inferences, procedures, while lacking adequate, strong, explicit evidence. They appear when the normal algorithms underestimate the true willingness of you towards your constant contact, because it fails to collect sufficient explicit evidence online proving your design to interact. Yeah, for example, if you and a colleagues in the same office, that one day you read some articles and the topic that really interesting, that you want to share with the colleagues, that as normal people you don't do it on internet, because you and a colleagues in the same office, that you can just talk to him and you can share your ideas and design interaction face to face. That in that way, there is no explicit interaction history can be traced, that showing your willingness towards your colleagues, because you finished it by talking to him directly face to face. So in that way, the blind spots will occur. Okay, the core idea of blind spot detection is to observe the contradiction of explicit willingness obtained by tracing interaction history and hidden true willingness oriented from social circle. Yeah, I feel like the interaction history. If you have experience using Facebook and 人人, that you have some contacts and friends in your list, that every time they update the pictures, the profiles, the status, that you will comment on them, and other times just share some links and click the likes button. Yeah, that is can be traced, because it's explicit interaction history that is online, that can be collected by someone else and can be seen by someone else as also. But as I said before, the example that you and the colleagues in the same office, that you want to share something, and talk to each other. You don't have to do it online. So this in this situation there is no interaction history that can be traced. Okay. Social circle, yeah, it is name often used by observer outside. From the observer's point of view, members in social circle should have something common like habits, interests, and even live closely. That means an observer does not need to follow everyone in a circle to acknowledge the features of social circle because he deems the members equally that he knows the circle just by following one of his members' pattern. For example, that if A and B and C plays for in the basketball team and D is not, and actually A and B and C doesn't have a strong feeling and they don't just realize that every day that they are in the same organization. We say they are same social circle. But D knows that A and B and C plays for a basketball team that is not, and you know if D wants to know something about the basketball team, the training, the games being played, and the results of the game, that he just doesn't need to follow A and B and C at the same time. That's impossible. That he just need to follow A because A is a member of social circle. That A is the member of basketball team. That if D can follow A, he knows everything about the basketball team. He don't have to do it on B or C because it's repeated word. Okay, the blind spot detection. The willingness score of a circle is average value of the willingness score of all members of a social circle. We need to pay attention when the willingness score of a member is dramatically below the willingness score because it is time blind spot detection is triggered. Okay, the following equation describes mathematically the detection blind spots. Look at the equation. Here, the WI means the a member's winning score, and WC means the social circle's winning score. And if BI equals 1, that means one of the members' winning score is below or less than the circle winning score. So that time the BI means the ith member of the social circle. So if BI plus 1, there it shows that the ith member of the social circle, you may have a blind spot. Okay, here's the experiments and evaluation. Look at this picture. From this picture, we can see clearly that how a social circle forms. That each node represents a user and it is distributed scarcely in a certain scale. I use the coordinate x to locate each node, and a social network is built by clustering nodes close to each other into a social circle. Look at this picture. Left, the nodes are distributed scarcely in the universe, and then in the right picture that some nodes are clustered into a social circle and into a social network. This threshold value of distance step before, because we have to make sure that the nodes in the cluster they just close to each other, not too distant. And here is the cluster, and which cluster and the cluster contains some nodes. Of course, choose the social circle each node is in after clustering. Figure 2, as described before, nodes which are close to each other are clustered into a circle. So these members in the same circle will share something common. We just like that, we assume that these nodes are close to each other, just like the users. They have something common. They share some common habits and topics every day. And this is a picture of a normalized willingness. And the figure visualizes the process detecting blind spots with x-axis representing circles and the y-axis representing the normalized willingness score. Look at the error bar in the standard deviation of willingness score distribution of single social circle, including the blind spots. For example, if like look at circle 1 and circle 3. Let me say first, there were 65 participants in my experiment that I divided into 8 groups, like 8 social circles, of course, and each social circle contains 6 to 8 members. So look at circle 1 and 5, there is a error bar in the bottom of the axis that they enlarge the standard deviation that we can see that in each circles there is always a error bar at the bottom of the normalized witness. So these are all the candidates of blind spots. Blind spots will definitely contradict social patterns, of course. And the last figure demonstrates the ground truth of circle witness scores. Okay, the ground ground truth is collected by asking zero question to the participants. Like you make an important contact and his or her updates relates to you and really care him or her in real life. For some questions that the participants have a score range 1 to 5, 1 meaning strongly disagree and 5 meaning totally agree. Thus we can convert this to willingness score scheme where 1 represents least willingness and 5 represents more willingness, most willingness, without any doubt. The calculated circular willingness score distribution obeys ground truth. So as detection results of blind spots, the blue curve represents willingness score of 8 circles. Detected blind spots when some circles willingness score are higher than average willingness score of 8 circles. Look at in circle 1 and circle 5, I said before that they have some blind spots which the willingness score is relatively higher than the average willingness score. In circle 1 and circle 5 that the candidate blind spots may be real. I have did some related work because I read a lot of paper about this topic about the social relation management, the social relationship ties and people's relationships, all kind of stuff like that. It's actually the projects involve some sociology work that because you have to this man-to-man communication and interaction that you have to get a basic understanding of how people interact and connect. So there is basically 3 types of inferences. Like the first is social type-based inferences, the 2 is the homophily based inference, and third is content-based inferences. And if you want to know this 3 types of inference in details, and you can always Google or go to Wikipedia. Yes, I just do some related work. Okay, finally, here comes the conclusion and summary. Well, in my project, blind spots are detected by contradicting explicit willingness evidence and deduce implicit willingness. I did some experiments using my random data to testify its validity, and to some degree turns out effective because the reason I choose Zerner is because Zerner is it's very popular in China, and I can have some permission to the data of my friends. But the Facebook I seldom use them, so I can't connect enough data to conduct my experiment. Because Zerner uses P2P technologies as most other social networks do, so the proposed scheme can also be applied to other systems, so long as it can collect sufficient data, evidences if you want to test. And of course, intensive experiments can be done with large amount of users and thorough statistic analysis, in which the results can be more precise and representative. In the future work, I tend to mix some more elements when developing willingness scoring model, like users' physical relationship with other people, users' implicit characteristics. That some people are shy and conservative, that some people are open and are easygoing, that they don't want to talk to others online, or they extremely design to share his feelings online or something like that. And emotions, of course, that it can, it's a big fact. Okay, here's end of my presentation. Thank you guys.